Hey everyone, I hope everyone are doing great. Myself Dinakar from Sri Venkateshwara College of Engineering. Today I'm gonna tell about computer networks in that congestion control algorithm. Moving on to the next slide. In this agenda we're gonna learn about many topics like general principles of congestion control, congestion prevention policies, congestion control in virtual circuits subnets, congestion control in datagram subnets, load shedding and control. Moving on to the next slide. In this, we're gonna see about conjunctions. When too much traffic in of offered conjunction sets in and performance degrade sharply. As you see in this picture, the rise you can see that is called as perfect. The curve is known as describable, and you can see about the maximum carrying capacity of subset. Moving on to the next slide. In this slide, we're going to see about general principles of congestion control. First one, monitor the system detect when and where congestion occurs. Then, passing information to where action can be taken. Then, adjust system operation to correct the problems. Moving on to the next slide, congestion prevention policies. In this, as you see this table, they are divided like layer and policies. In layer, transport there are many further points like retransmission policies, out of order catch policies, acknowledgement policies, flow control policies, timeout determinations. In network, virtual circuits versus datagram inside the subnet, packet squaring and service policies, packet discard policies, routing algorithm, packet lifetime management. Then in data link, retransmission policies, out of order catching policies, acknowledgement policies, flow control policies. Then policies that affect conjunctions are, moving on to the next slide, conjunction control in virtual circuit subnets, admission control. First, as you see in this diagram, the first one is known as a congested subnet. The second one is known as a red drawn subnet elements conjunction and a virtual circuit from A to B. Moving on to the next slide. In this slide, we're gonna see about conjunction control in datagram subnets, wiring bit. The old descent and frame relay networks, a warning bit is sent back in the act to the source in the case conjunction. Every router on the path can set the warning bit. It is denoted as U new equals AU old plus 1 minus AF. Each router monitors its utilization U based on its temporary utilization F either 0 nor 1 is a forgetfulness rate. If U is above a threshold, a warning state is reached. Moving to the next slide. Hop by hop choky packets in high speed nets. In this 30 ms for a choke packets of get from NY to CSF for a 155 Mbps, 4.6 megabits gets in the pipe. A. A choke packet that affects only the source. B. A choke packets that affects a hop in passing through. As you see in this picture, the how the flowchart from A part to E path, then E path to F path to D path it goes. You can see. And moving on to the next slide, dropping packets, loading, shedding, wine versus milk. Wine, a drop new packets. keep old, good for file transfer. Milk, drop old packets, keep new, good for multimedia. Random early detection. When the average queue length exceeds a threshold, packets are picked at random from the queue and discharged. Then moving on to the next slide. In this slide, you're gonna say about jitter filter. The first option is known as high jitter. The second option is known as low jitter. In this first option, you can see the graph, and this graph, higher graph is known as fraction of packets. The lower graph is known as delay. The width is called as high jitter filter. The low width is called as low jitter filter, and this minimum delay due to speed of light. This is low jitter filter and this is delay. Moving on to the next slide. Thank you. I hope everyone understood. Please do like, share and subscribe my channel. Thank you.